Hello, in this video we're going to take a look at the rational zero theorem. So the rational zero theorem tells us that if we have a polynomial that has integer coefficients, so all of the coefficients on x, there's no fractions, they're all integers, then any zero that is a rational number will be in the form of a factor of our constant divided by a factor of our leading coefficient. And so what we're going to do here is we are going to list out the possible rational zeros. We're going to find some that aren't going to be zeros, and we will not list out anything that could possibly be a zero. We are only looking for those that are rational zeros, so meaning something that we can factor and solve for x, and we get a fraction of a whole number divided by a whole number. All right, so as we are looking at this, the only thing we are interested in is our leading coefficient, that leading term, and our constant. So we have the polynomial f of x equals 3x to the fourth minus 6x cubed plus x squared minus x plus 1. But we are only interested in that 3x to the fourth out front and that 1 at the end. And so we're going to look for factors of that constant, in this case the 1 on the end. Well, the only numbers that multiply and give us 1 are, we can multiply 1 times 1, or we can multiply negative 1 times negative 1. And then for our leading coefficient, factors of the 3 there, well, the only thing we can multiply and get 3, we could do 1 times 3, or we could do negative 1 times negative 3. So our possible rational zeros are going to be any combination of a number from our top list divided by a number from our bottom list. So we could do 1 over 1, that gives us 1, negative 1 over 1, 1 over 3, negative 1 over 3, and then 1 over negative 1 is already on our list, 1 over negative 3 is on our list, negative 1. It's always going to work out that we have both the positive and negative versions of each of these combinations. And so the possible rational zeros for this polynomial, it has a leading coefficient of 3x to the fourth and a constant value of 1, is 1, negative 1, 1/3, and negative 1/3. And we will use this to determine one of our zeros and try to factor it from there. But this will be our starting point instead of just randomly picking numbers and seeing if they give us a 0 to that function. We've narrowed our list down from every possible number, every possible rational number, to these 4. So that means that there is no way that x minus 4 is going to be a factor of this, because we do not have that 4 in our list. The only factors that we could get are going to be x plus 1, x minus 1, x plus 1/3, or x minus 1/3. All right, so let's do another one of those. This one, we've got a leading coefficient. Our numbers are a little bit bigger, so we'll get a few more combinations. We're still going to look only at our constant and only at that leading coefficient. Our polynomial here is f of x equals 22x to the fourth minus x squared plus 121. So the first thing we want to look for are the factors of our leading coefficient, the factors of the the factors of our constant, the factors of the 121. 121 is 1 times 121. I'm going to go ahead and list them with a plus or minus. All of these are going to come in a positive or negative form. So 1, 121. 121 is 11 squared. So, and 11 is a prime number. So that's going to be all of the factors. And then we're going to do the same thing with our leading coefficient. So our factors of 22, we've got 1 and 22 and 11 and 2. And so our possible rational zeros here are going to be any combination of something from the top list divided by something from the bottom list. You always do factors of the constant divided by the factors of that leading coefficient. So we're going to have 1 over 1, which is 1. We're going to have plus or minus on all of these as well. 1 over 22. 1 over 11. 1 over 2. 121 over 1, which is just 121. And then 121 over 22 is going to reduce to 11 over 2. 121 over 11 reduces to 11. And then 121 over 2. And then we're going to get 11 over 1 is already on our list. 11 over 22 reduces to 1/2, and that's on our list. 11 over 11 is 1, which is on our list. And 11 over 2 is already on our list as well. And so this one, instead of having the 4 that we had on the previous, we've got plus or minus on each of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possibilities. So this one's got a little bit more. I would definitely start with the plus or minus 1 first. That typically is going to work most often. All right. I'll see you guys next time.